Hello everyone, welcome back to part 2 now of the chapter 2 review. In this video we're going to go through a little bit more details about equations involving circles. So let's start with this first one here. Write the standard form of the equation and the general form of the equation of the circle with radius r and center h, k. Then graph the circle. So just to review real quick, the definition, what exactly is a circle or what makes a figure a circle? A circle is a set of points in the xy plane that are a fixed distance r from a fixed point h, k. The fixed distance r is called the radius, and the fixed point h, k is called the center of the circle. So with my little figure that I have drawn here, let's zoom in a little bit more. We would say that this point right at the very center is this h, k value. And the circle, all the points on the circle are supposed to be a fixed distance from this center point. So you pick any value, any coordinate pair, any x, y combination that is on this circle. All of these points are equidistant from the center point. Now, equidistant, we call that the radius. All of these points from the point on the circle to the center point, they have this distance r. So let's pick one of these random points that we have drawn here and call it some xy coordinate pair. The distance from that point to the center is defined by this value r. Well, from the previous video and from previous studies in chapter 2, we know how to find this distance r. R is supposed to be the square root of the sum of the differences between the x values squared and the difference of the y values squared. So in essence, this is the distance formula here. We know how to plug and chug these coordinates into the distance formula. If we, just want to get rid of that square root and make it look a little bit more like friendlier equation, we could square both sides and be left with this equation, the quantity x minus h squared plus the quantity y minus k squared equals r squared. We call this the standard form of the equation of a circle. And it's literally just from the distance formula, knowing two coordinate pairs in the plane. So all coordinate pairs, you pick another xy pair that is on the circle with this center point hk, and you're going to plug it in and find the exact same equation of a circle. Now, the general form comes from just expanding out this standard form. So if we did the FOIL on each one of these quantities, that's what we would call the general form of the equation. So it's written something like x squared plus y squared plus ax plus by plus c equals 0. So we would combine like terms, all the x's would go together, all the y's would go together, all the constants would go together, and again, we would call this the general form for the equation of a circle. This one in the box here is what we call the standard form. Okay, so let's zoom back out and tackle our problem. We want to write the standard form of the equation that has a radius of 4 and a center at -4, 0. So I'm just going to plug and chug these values into my known equation for the standard form of a circle. So we'll copy it back down here. X minus h quantity squared plus y minus k quantity squared, that is supposed to be equal to r squared. And h and k are given to me. They are, again, the center of the circle. So I'm going to substitute in -4 for h, and we're going to substitute in 0 for k, and then 4 for r. A little bit of simplification here. Add the opposite. We've got x plus 4 quantity squared. Y minus 0 is just y, so then plus y squared equals 4 squared is 16. So this is the standard form for the circle with these characteristics. If we want to go ahead and find the general form of this same equation where the radius is 4 and the center is at negative 4, 0, all we have to do is expand out by foiling. So maybe I'll continue with a different color here. So expanding out x plus 4 quantity squared, this would be x plus 4 times x plus 4 plus y squared equals 16. So first outside, inside, last, we've got x squared, and then 2 4x's, so we've got 8x's, and then 4 times 4 is 16, plus y squared equals 16. And then we want to put it again in this general form where all of the variables, all the constants, everything is to one side and it's set equal to 0. So I would want to move this constant over and collect any like terms. So we would be left with x squared plus y squared plus 8x. And the 16s would end up canceling, right? If I subtract 16 from the right-hand side, I do it to the left-hand side, I would get 0, and then I would also have 0 constants. So the general form of the equation is here at the bottom, x squared plus y squared plus 8x equals 0. That's what we're calling the general form of the equation. Now, let's take a moment here and graph the circle. The center being at negative 4, 0, negative 4, 0 would put our center right about there. The radius is 4, so that's going to be a distance of 4 kind of in all vertical and horizontal directions. So I know another point of the circle would be here. 1, 2, 3, 4, immediately opposite, but to the left, another point would be there. 1, 2, 3, 4. There's another point on the circle. And there's a fourth point on the circle. So that gives me a general idea about how to draw my picture, which again, on the computer is kind of difficult to do, but that's a general sketch of what the graph of my circle would look like. I would have 2 x-intercepts, a y-intercept if I'm counting, you know, the touching and the turning that's going on right here at the origin, but that's a general sketch for you. All right, number 2, for the equation x squared plus y squared minus 6x minus 4y minus 3 equals 0, we want to do the following. We want to find the center point, and then we want to find the radius. Okay, well, that's a little difficult to do whenever the equation is written in general form and not standard form. So my first step in order to figure out these two values is to rewrite the given equation in standard form, because I know I can pick out h and k and r from the standard form of the equation pretty easily. Remember, it's x minus h quantity squared plus y minus k quantity squared equals r squared. So if I can just rewrite this general form of the equation in the standard form of the equation, it'll be pretty easy to pick out the center point and the radius. So to do that, really what we want to do is complete the square on both of the variables. So let's copy down the equation here. X squared plus y squared minus 6x minus 4y minus 3 is 0. My first step is that we want to group the variables and then move the constant. I want to kind of get it looking in this standard form. So let's group the x's together. We'll say x squared minus 6x, group those together. And then group the y's together, y squared minus 4y. And then move the constant, if it's on the left-hand side, move it to the right-hand side. So I'm going to add 3 to both sides. All right, now my second step is that I'm going to complete the square in each set of parentheses, so for each one of the variables. For each variable. Okay, now to complete the square, we remember that you take the coefficient that is sitting with x. So in a regular like quadratic equation, general quadratic equation, we've got something like ax squared plus bx plus c equals 0. To complete the square, we take the coefficient that is sitting with x, so we'll call that b. We divide it in half, and then whatever that quantity is, we square it. That's what's getting added to both sides, like a balancing act. We're going to do this step. We're going to do this step for both x and y. Okay, so I'm actually going to leave it in green so we can see this step happening in action. We're going to take this term that is sitting with x. This is going to be like the coefficient b. We're going to take that value, I'll do it off to the side here, -6. We're going to divide it in half, that would be -3, and then we're going to square it. -3 squared is going to be 9. So to both sides of the equation, I'm going to add the value 9. I'm going to add it here to complete the square, and then I've got to add it to this side to balance it. So completed the square with x, and I balanced it on the other side. I want to do the same thing for the variable y, but this time my coefficient with the single variable y is not -6, it's -4. So completing the square on y, we're going to take -4, divide it in half, and then square it. Well, -4 divided by 2 is -2. -2 squared is 4. I'm going to add 4 to both sides to balance it and also complete the square on the other variable. Okay, so in doing this, now what I have in parentheses are perfect square trinomials. They will factor as a binomial squared. The first one is going to factor as x minus 3 quantity squared. And the second set of parentheses is going to factor as y minus 2 quantity squared. Now, on the right-hand side, what do we have? We've got 9, 10, 11, 12, 13, 14, 15, 16. On the right-hand side, well, that's convenient because that is a perfect square of 4. So my equation of this circle in standard form is going to be x minus 3 quantity squared plus y minus 2 quantity squared equals 4 squared. And because it's written in this way, I can pick out all of these values that match the standard form. So for instance, on the right-hand side, I've got my r squared, so I know r must be 4. The radius is equal to 4. So radius equals 4. And I can also pick out my center points because they are in the quantities with the variables. Now you do have to be careful here because notice that it has to be written x minus something, and y minus something. So if the quantities after completing the square are not in terms of a difference, maybe it's in terms of a plus sign. Like for instance, maybe after completing the square you have something like x plus 7 quantity squared. You can turn that into a subtraction problem by saying x minus a -7, in which case h would be -7. But conveniently enough for our problem, both of the quantities are already in terms of subtraction, so we don't have to worry about that. But, for the test, for future reference, if it's not written like a difference in here, if this is an addition sign and not a subtraction sign, then you want to adjust the way it's written so that it is a difference and you get the correct sign, positive or negative, on your values h and k. But again, they are as differences here, so I don't have to worry about that. This guy must be h, and this guy, according to my standard form, must be k. So the point h comma k is 3 comma 2. And those are what I'm supposed to find in part A of this problem, the center point and the radius. Okay, now that I have those two things, it should be easy enough for me to graph the circle. It's not maybe obvious when you sketch it out on paper, but we're looking for, again, the places where we're crossing the x and the y axis. So in this picture, we really have 4 places that could be, right? This looks like an intercept right here. This looks like an intercept. This looks like an intercept. And this looks like an intercept. So, I mean, those aren't falling nicely on integer values on the xy plane. So I can't eyeball it or estimate it, but I do know that if I let x and y be 0 respectively, I can solve for those values. So again, my x-intercepts are going to happen wherever we let y be 0. So let's first figure out where those points could be at. So we're going to say x minus 3 quantity squared plus y minus 2 quantity squared equals 4 squared, and we're going to plug in 0 for y. So x minus 3 quantity squared plus 0 minus 2 quantity squared equals 4 squared. Solving now for x, we've got the quantity x minus 3 times x minus 3, that's x minus 3 squared, plus negative 2 squared would be 4, and 4 squared is 16. All right, so now we've got x squared minus 6x plus 9 plus 4 equals 16. Well, 9 is 4 and 4 is 13. If I subtract the 16 over, I would have x squared minus 6x minus 3 equals 0. Okay, well, I can't nicely factor this by looking for two things that multiply by to be negative 3 and add to be negative 6, but I could use my quadratic formula to solve for my roots of this equation. So x is equal to the opposite of b, which would be positive 6, plus and minus the square root of b squared, which is negative 6 times negative 6, 36, minus 4 times a, which is 1, times c, which is negative 3, all over 2 times a, which is 1. So little simplification, x is 6 plus or minus the square root of 36 plus 12, negative 4 times negative 3, all over 2. So we've got x is 6 plus or minus the square root of 48, all over 2. Well, 48 is the same thing as 2 to the 4th times 3. So this will simplify as 6 plus or minus 4 square roots of 3 all over 2. And this 2 can cancel out a factor of 2 in both 6 and 4. So the whole thing is going to reduce to 3 plus or minus 2 square roots of 3. Now, all this came again from allowing y to be 0. So these were the x-intercepts of our graph. So that means that this point right here and this point right here, they will have x coordinates of 3 minus 2 square roots of 3 and 3 plus 2 square roots of 3. Now we're going to do the same song and dance on the flip side, finding the y-intercepts by letting x be 0. So we're going to plug back into our equation of the circle. So we're going to say 0 minus 3 quantity squared plus y minus 2 quantity squared is 16. So 9 plus the quantity y minus 2 times itself is 16. So we've got 9 plus y squared minus 4y plus 4 is 16. 9 and 4 is again 13. If I subtract the 16 over, we've got negative 3 equals 0. And again, this does not factor nicely as two quantities where we can multiply to get negative 3 but add to get negative 4. So we've got to again use our quadratic formula and say that y is equal to the opposite of b, which in this case is the opposite of negative 4 or positive 4, plus and minus the square root of b squared 16 minus 4 times a times c, all over 2 times a. A little more simplification, 4 plus and minus the square root of 16 plus 12 all over 2, which is 4 plus and minus the square root of 28 all over 2. Now 28 is 4 times 7, so a 2 is going to come out of there. 4 plus and minus 2 square roots of 7 all over 2. And the 2 in the denominator is going to cancel out factors of 2 in the numerator. So we have y is 2 plus and minus the square root of 7. And these are, again, the y coordinates of our y-intercepts. So we have the points 0, 2 plus the square root of 7 and 0, 2 minus the square root of 7. So this one up here is likely to be 0, 2 plus the square root of 7. And this one down here is likely to be 0, 2 minus the square root of 7. Alrighty, let's continue on and do another one very similar to this last one, except what if the equation already looks as if it's kind of in standard form? What if it's not fully in a general form of the equation? Can we still do the same kinds of instructions? Finding the center, finding the radius, graphing it, finding the intercepts. Can we still do all of that stuff? So this time our equation is 2 times the quantity x minus 5 quantity squared plus 2y squared equals 18. Okay, well, this is telling me that I kind of already have it in standard form. I just got to do a little bit of algebraic manipulation to make it look like the standard form that I know, x minus h quantity squared plus y minus k quantity squared is equal to r squared. So really, I just need to make the y quantity look like y minus something. So we've got 2 times x minus 5 quantity squared plus, now I could, this is kind of a trick, I could just rewrite this as y minus 0 quantity squared, right? Because adding or subtracting 0 to y isn't really going to change anything. I'm just kind of forcing it to look like y minus k equals 18. Now I'm almost there. Notice that there are no coefficients, no factors sitting in front of these squared quantities. So my next thought is to make it look like standard form, I really should try and get rid of these 2's. And the easiest way to do that, since they're both the same coefficient, is just to divide them away. So divide the left-hand side by 2, divide the right-hand side by 2. Now I've got x minus 5 quantity squared plus y minus 0 quantity squared is equal to 9. So now I've got it in the x minus h quantity squared plus y minus k quantity squared equals, now I've got to make sure the right-hand side looks like something squared, and conveniently enough, 9 is the perfect square of 3. So my equation in standard form looks like the quantity x minus 5 squared plus the quantity y minus 0 squared equals 3 squared. So now it's super easy to pick out all of these values. My radius is clearly 3, and the center point is 5, 0. So h, k is 5, 0. And that's enough for me to graph the circle. So there's my circle with the center point at 5, 0, a radius of 3. What I want to answer now is the intercepts, if any, of the graph. It's pretty clear that we're not going to be crossing the y-axis on this one, but we definitely have 2 x-intercepts. Since this one falls nicely on integer values of the xy plane, we can just visually see that these intercepts are going to be three values of x below the center point and 3 values of y, or 3 values of x above the center point. So those are going to happen at 2, 0 and 8, 0. But what if you tried to answer this question before you graphed it? Would there be any cues along the way that tell you that there's no y-intercepts and that there are 2 x-intercepts? So let's actually go through the math real quick just for sake of argument, to show mathematically, algebraically, that we're not going to find values for y at which the graph crosses the y-axis, and we will find 2 values for x. So let's show algebraically that there are no y-intercepts by letting x be 0. What happens then? If x is 0, I've got 0 minus 5 quantity squared plus y minus 0 quantity squared equals 9. Let's see what happens here. Negative 5 squared is going to be 25, and y minus 0 quantity squared is going to be y squared equals 9. And we'll have y squared equals negative 16 whenever I move that 25 over. Okay, at this point right here, this is where some red flags should be going up pretty quickly. We have a squared value equaling something negative. Say what? That's never going to happen, right? Squared values are always positive. So at this point in my solution process, I should be thinking, okay, there are no y-intercepts, because as I'm going through and doing this algebra, I'm getting a contradiction here. So there's no solutions to this equation, meaning that there are going to be no points at which we're crossing the y-axis. So I move on. I want to find now if there are any x-intercepts, in which case I am going to let y be 0. And we're thinking from the graph we should come up with 2, 0, and 8, 0 at the end of this. So if I'm letting y be 0, I've got x minus 5 quantity squared plus 0 squared, which is 0, is supposed to be equal to 9. So we've got the quantity x minus 5 quantity squared equaling 9. To get x by itself, I've got to get it outside of this squared quantity. So I'm going to take plus and minus the square root of both sides. And this one then be x minus 5 equals plus and minus 3. So x equals 5 plus 3 and 5 minus 3. 5 plus 3 is 8. 5 minus 3 is 2. Hey-oh, there's the 2 values that I was looking for from my graph. Now again, this kind of scenario might not always happen where, the graph of the circle is falling nicely on integer values. Kind of like up in the last problem that we did, all of those intercepts did not fall nicely on integer values of the coordinate axes. So you're going to probably have to do some algebra, letting x be 0, solving for y, letting y be 0, solving for x, and finding those intercepts on a regular basis. So don't assume that you should always graph it first and then just eyeball these values. That's not always going to be the case that they're going to come out nicely like this. So definitely take some time and do the algebra to figure out what those coordinate pairs should look like. So that's where I'm going to leave you. Those are the examples that I wanted to go over with you just to make sure we had the vocabulary and knew the difference between the standard and the general form for the equation of a circle, and really just to get some brush up on the algebra that's involved, because it's a little bit more intensive in section 2.4. So let me know if you have any questions, and I'll let you go.